We're still going to be using interval notation on this last portion. We're going to use interval notation to express different characteristics of given graphs or functions. Specifically, we're going to be expressing the intervals where your graphs are increasing, decreasing, constant, positive, and negative. When a graph is increasing is simply the interval where the graph is going up. The y values are rising. Since we read our graphs from left to right, let's recognize that that would be this portion of graph from left to right that's increasing, and then this second portion. Now, something to notice. Whenever you tell me the intervals where your graph is increasing, decreasing, or constant, or positive or negative, you will always state the interval in terms of the domain, in terms of the x values from left to right. We're talking about where the y's are increasing, but we're using the interval from left to right on the x-axis, like our number lines in the beginning of this lesson. When you decrease, it's just the intervals where the graph is decreasing from left to right. So that would be our red portion. When a graph is constant, it's the portion of the graph where the graph is flat. It doesn't change. The y values don't differ. They stay the same. Now, I'm going to erase those three because they're already labeled on your graph. And now let's talk about positive and negative. When I ask you for intervals where the graph is positive, what I'm asking about is where is the graph above the x-axis? It's where the y values are positive. So everything above the x-axis would be this portion of graph from left to right. All of those are above the x-axis. All the y values of those ordered pairs are positive. That's what I'm saying. When I ask you about where the graph is negative, it would be all of the intervals where the graph is below the x-axis, where the y values are negative. On this particular example, that would be this portion and this portion on the far left and the far right, because those are all the values that are below the x-axis, where all the y's are negative. Keep in mind, when you're being asked about positive or negative, 0, aka the x-axis, is neither positive nor negative. It's neutral. So if a graph touches the x-axis, touches 0, it's going to have to get a parenthesis. It's going to have to break at that intercept. Okay, let's actually practice this. Increasing, decreasing, constant, positive, and negative. Now, one thing I want to change about this graph is I want to make sure you know that that's going to have an arrow for forever. This ordered pair right here is just a reference point so you can see things like slope, just connecting different parts of the line segments together to make this one graph. So don't let that point fool you or make you uncomfortable. All right, let's start with increasing. Where is the graph increasing? Well, since you are reading this graph from left to right, we have decreasing, constant, decreasing, and increasing. So here is the portion where the graph is increasing. This is the ordered pair from the left of 3, negative 1. That's the x and the y. And then our endpoint stops at 4, positive 1, the x and the y. Now, what I need you to remember is that you need to always tell me each of these intervals in terms of the domain, in terms of the x's. So it's great that you already know that the y values are there, but they're not what's important right now. So I'm going to highlight them, circle that. We're talking about 3 and 4. So from where on your domain are the values increasing? Yes, I know we're talking about the y values increasing, but you're telling me in terms of x. So where is the graph increasing? From 3 to 4. Brackets or parentheses? I'm glad you asked. When we have a portion of graph that is changing direction. We call it a changeover point. This point right here, this 3 comma negative 1, this is a changeover point. Changeover points always get parentheses. You might want to know why. I want you to think about this. If you're on the Texas Giant or any roller coaster, you are going up this giant steep hill. And when you get to the top of it, there's a moment where you're no longer increasing, but you haven't started decreasing and then lost your lunch. That moment, that pause, is the changeover point. At that moment, are you actually increasing? No, you're pausing before you begin your descent. Are you decreasing? No, you're pausing before you decrease. That split second doesn't have increasing nor decreasing. So we're going to put a parenthesis around that because a bracket would be telling us that it does include an increasing portion, an increasing part of the graph. But at that moment, at that hill or that valley, whichever one's appropriate for your graph, it's neither decreasing nor increasing. It's pausing to change direction. That's a changeover point. This graph has 3 changeover points. We change from decreasing to constant. We change from constant to decreasing again. We change from decreasing to increasing. Now, your end point over here is an arrow going on for forever. So don't worry, again, disregard that guy right there. Your endpoint on the far right side is great, but are you changing? No, you're ending. So this one's not a part of the equation just yet. So for our interval, are you changing? Yes. So can you say you're increasing? No, you cannot. Changeover points always get parentheses when we're talking about increasing, decreasing, or constant, because they're pausing to change direction. They're no longer increasing nor decreasing, nor are they constant. Now, let's talk about the 4. The endpoint, this is actually a long debated topic in the math circles. So what's awesome is that you really can't go wrong either way. There are some people in the math community that would argue that an endpoint is ending. It's no longer increasing. So you would also put a parentheses like that. There are other people in the math community to be like, whoa, 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 hold up. We believe that it is increasing there and that it's ending, it's a closed circle. We're going to put a bracket there and we're going to show that with a bracket. You can argue either side, actually, any way you want. It doesn't really matter. And we actually talked to our calculus teacher to make sure what College Board says, and we will go with what College Board says. And thankfully, College Board says they don't care. So, for argument's sake, to keep it easy, we're going to put a bracket there because we have that closed circle anyway. So we're not going to confuse. We're just going to be like, endpoint's closed, put a bracket, endpoint's open, put a parentheses, done and done. We're decreasing. We stop to change directions. We pick back up decreasing, and then we stop to change directions. We're decreasing. So from left to right, we are decreasing from this pointing arrow, which from the x's perspective, not from the y, because you have to tell me the interval in terms of the domain. If I were to write the arrow as an ordered pair, I would write it as negative infinity, comma infinity, because it goes to the left forever, which would be the x value of that arrow, towards negative infinity, and then it goes up forever, which would be the y value of that arrow. Since we talk about all of these intervals in terms of the domain, we only need to represent it as going to the left forever. So our first interval from left to right would begin at negative infinity. Now that portion of graph that's decreasing, it stops at the changeover point. That changeover point is at -4. Change over points get parentheses. No argument there. Now, we're going to union that graph with the other portion that's decreasing. From this change over point to this one. This ordered pair is at -1, 2. Again, we are only talking about the x's when we talk about the intervals that we're representing. So from -1 with a parentheses, because it's a changeover point, all the way to +3, again, changeover point with a parentheses. That's the other portion of graph where the graph is decreasing. Now let's do constant. Our graph is constant in only one portion, this section of graph right here. That is from the ordered pair -4, 2 to -1, 2. Since we're talking about the domain for all of these, we're talking about left to right, we need the -4 and we need the -1. So our interval is from -4 to -1. Now both of those numbers are connected to changeover points. And changeover points get parentheses when we're talking about increasing, decreasing, and constant. So both of those would get parentheses. It'd be parentheses -4, -1 parentheses. Now it's time to talk about the portion of our graph where our graph is positive, aka above the x-axis. Above the x. All of our positive values of graph are going to be from far left to far right, the arrow to where you're about to hit the x-axis. That is every portion of the graph that's above the x-axis, where the y's are positive. And again, we're talking about what y is doing, but we're saying it in terms of left to right, the domain, the x's. So from far left, that would be this arrow represented on the x-axis as -infinity. And infinities always get parentheses, all the way to where we hit the x-axis. Now remember, the x-axis is neutral. So you can say, and just for argument's sake, we're going to keep it easy. It looks a little bit past 1.5. So I am just going to keep it super simple. And I'm going to say that that ordered pair right there is 1.75, 0. And again, we're only wanting the x values when we talk about these intervals. So we're going to say from -infinity all the way to 1.75. If you chose 1.5, that's fine. It's not obvious, so we're going to leave it be. Or 1.6, or I don't know, it doesn't matter. So we're not choosing the y value, we're choosing the x's. Now, the reason why it gets a parentheses, that's because 0, the y value, is not positive nor negative, it's neutral. So when it hits the x-axis, you gotta go neutral. You can't bracket it, you cannot include that value. That is not the same as the reasoning behind changeover points. I'm asking a different question. I'm not asking where the graph is increasing or decreasing and where it's changing direction. I'm asking where are all the graph's values that are physically positive y's, physically above the x-axis. Okay, now, this is all fantastic, but hopefully you didn't miss out on the fact that there's actually more graph that's above the x-axis. The other portion of graph is here. So I need to rewrite this, and I need to make sure I leave room for a union, because I'm going to have a separate portion of graph. So writing a little bit smaller this time, I'm still going to have that -infinity to 1.75 with a parentheses around both. Then I'm going to get ready for the union, the other portion of graph. Now, for argument's sake, let's say that this ordered pair is straight up 3.5, 0. That's the x and the y value. And yet again, we're only using the x. I'm going to put a parentheses, 3.5, as the left portion of that interval. It gets a parentheses because, again, it can't get a bracket when it hits the x-axis. It's neutral, so it doesn't get a bracket to say it's positive and included in those values. Interval is actually an ordered pair that is above the x-axis with an actual endpoint. That is the ordered pair 4, 1, x, y. So from 3.5 to 4, your graph is above the x-axis. It's positive as well. So, bracket or parentheses. Ask the question, is the y value neutral and therefore needs a parentheses, like both of these here? Nope. Is it in fact positive? Is it in fact located above the x-axis? Yeah, it is. So when that's the case, you actually get to put a bracket. You get to include that value. For the last portion, we're going to talk about where the graph is negative, aka below the x-axis. Thankfully, there's only one portion of graph that's below the x-axis, and it's that V-shaped portion of graph right there. Now, if we're looking for every y value below the x-axis, again, you're still telling me in terms of the x values. So that's going to be the chunk of graph from far left to far right that's below the x-axis. That would be 1.75 all the way to 3.5. It is not a coincidence that that is basically the gap where it wasn't positive, because really there's only two options. It's either above the x-axis and it's positive, or it's below the x-axis and it's negative. I guess it could be on the x-axis, but then it wouldn't answer any of those questions either. So, that being the case, we put a parentheses around both because the x-axis is neutral, therefore it is not negative and cannot be included as such. Okay, last example. The first thing that I'm going to do to help make it a little bit easier is I'm going to mark down important points and make sure I understand what exactly they are. On the far left, our first ordered pair that looks important is -4, 1, where the x is -4 and it's an endpoint. I'm going to notice that that endpoint is closed, so I'm going to think about making sure I recognize the need for a bracket whenever appropriate. Now, this point might seem important, but nothing's happening here. It's not changing direction. I don't think it's really that big of a deal. It's just there for your reference. The next important point would be this guy. That ordered pair is at -2, 3. And I'm going to notice that that is a changeover point, which will be really important to recognize whenever we're talking about increasing, decreasing, or constant. This point always fools everybody. If you're actually following along, this graph is decreasing, and when it hits that point, nothing changes. Yes, it is technically changing from like a straight line to a curve, but that has nothing to do with any of the things you're being asked about. So that whole section of graph, though it looks kind of funky, is still just decreasing. So that point doesn't really mean anything. I will notice for later, whenever I do positive or negative, that point does represent a point that hits the x-axis. So I'm going to be keeping that in mind for positive and negative, but not for increasing, decreasing, or constant. Now here we have another changeover point. That's the point 0, -1. And we're definitely changing from decreasing to increasing at that point. This point, the point 1, 0, is actually going to be in play in more than one occasion. One is a changeover point. It's changing from increasing back to decreasing as you travel from left to right. But also, when we deal with positive or negative, it's hitting the x-axis and going neutral. I'm going to keep that in mind for later. The last important point is this guy right here, the other endpoint. I'm going to notice that the coordinates are 3, -1, the x and the y, and it definitely is not open. So I'm noticing that it's going to be closed. I'm going to make sure I get my bracket ready for that. It's not a changeover point, it's just an endpoint. It doesn't change direction, it just stops. Okay, so where is our graph increasing? I see an increasing interval from left to right here, and another one here. So from left to right, that would be -4 with a bracket, because you are allowed to put a bracket on an endpoint, especially when it's closed, all the way to -2. But that -2 gets a parentheses because it's a changeover point. It's not increasing anymore at that point. It's pausing to change direction. Now I need to union that with my second portion of graph. The x's would be from 0 to 1 from left to right, and both of those would get a parentheses because they're both at changeover points where the graph is changing direction. We always put a parentheses on changeover points. Where is the graph decreasing? So we have the decreasing portions of our graphs. The first one is the whole line semicircle combo. That's all decreasing as I traveled from left to right. And the second portion of graph is the last segment. So from left to right, x values only, that would be -2 to 0. Both of those would have a parentheses because they both are at changeover points. Union with +1 to 3. And +1 would get a parentheses because it's at a changeover point, but +3 would get a bracket because it's at an endpoint. And again, that can be argued either way, but we're just keeping it simple and doing endpoints as the brackets open, bracket closed or parentheses open as necessary. Where's the graph constant? There isn't a portion of this graph that's flat, so there isn't a portion of this graph that's constant. If an interval does not exist, one way to write that is simply doesn't exist. If you want, you could put NA or none, but D and E does not exist would be our preferred method. Positive, as in everything above the x-axis where all the y values are positive. It's going to be a little bit different on this graph. It might even fool a couple of you. First, notice that everything I'm highlighting is technically above the x-axis. So the only portions that I see that are above the x-axis is that crazy little upside down V right there. Now, some are going to want to tell me that there are two portions of the graph that you would need a union, but that's actually not true. I know that this portion of the graph does change from increasing or decreasing. That's not what I'm asking about anymore. I'm just asking where from left to right is the graph above the x-axis, where all the y is positive. So technically, that's just one interval. From far left of -4 all the way till it hits the x-axis at -1. That's where the graph is above the x-axis. Now, the -4 gets a bracket, not just because it's an endpoint. Really, that's not it at all. It's because the y is in fact positive. It's above the x-axis, so we get to include it. So it has nothing to do with it being an endpoint on this one. That was for changeover points and increasing, decreasing constant. This is it physically above the x-axis? Yes. Include it with a bracket then. Now, where it hits, we call them those neutral zeros. That would be at -1. Is it actually positive at -1? No, it's neutral. So any neutral zero is going to get that parentheses. So there's our only positive interval. I don't see anything else for the rest of the graph that's above the x-axis. So that's the only interval for positive. Now let's finish up with negative. The negative interval is going to be anything below the x-axis. believe it or not, that's actually two different portions of graph, because when it hits an x-axis, it goes neutral and can no longer be counted with negative. What that means is you will have the first portion of your interval from the neutral zero of -1 all the way to the neutral zero of +1, where your graph is below the x-axis. So from -1 to +1, both with parentheses, because they're both at neutral zeros and they can't be counted as being negative. There's your first interval. Because you hit the x-axis, you have to break it. You can't include that, so you can't just keep it going. So on the other side of the -1, 0, neutral 0, we pick up and we finish with the other portion of graph. That would be from +1, again with the parentheses, because you can't touch that +1, all the way to 3. That 3 gets a bracket, not because it's the endpoint, but because the y value is in fact negative, like what we're asking about. Now, you might think it odd that you've got 1s in both of these locations. But remember, a parentheses means everything up to it, but not yet including it. So those 1s aren't really 1. The 1 you see on the left is really 0.99999999999. I don't want to keep writing that anymore. And the 1 on the right, that's not 1. That's really 1.000000001. I don't want to write that either. So we write those whole number 1s and we use parentheses to show that it's right up to it, but not actually including the value. Okay, I hope you're okay. I hope this wasn't too overwhelming. Thank you for hanging in there with me. I know this is a long video. Good luck. If you have any questions, just ask, and we'll see you soon.